Let's say we have a function of two variables, x and y. Let's call this function the function f. We define the gradient of f. We represent it this way. We define the gradient of f to be equal to the partial of f with respect to x times the I unit vector plus the partial of f with respect to y times the j unit vector. But obviously, definitions are not coming out of nowhere. So what's really the motivation behind this definition? That's what we are going to find out. But first, we are going to look at what might seem a simple problem. Let's say you're here, right there, at the origin of those two perpendicular axes. Now I'm telling you that by going 1 unit in the y direction, up north, 1 unit in y direction, I give you $4. The same way, by going 1 unit in the x direction, 1 unit in x direction, going east, I give you $2. Now I'm asking you, which direction are you going to choose in order to make as much money as possible? Well, it seems like we should favor going up north, since it pays more, over going east. But before answering this question, let's first try a quick example. Let's say you've walked from the origin in this direction, and that you ended up to this point. How much money have you won? Well, first, the money you've won in the x direction. What is it? You traveled 2 units in the x direction. So the money you won in the x direction is equal to 2 times 2, $4. Now, you traveled 3 units in the y direction. So how much money have you won in the y direction? 3 times 4 equals $12. So by going to this point right here, you've won a total of $16. But maybe you would have won more money traveling the same distance d, but in another direction. Maybe, I don't know, going right here. So was it really the best direction to choose? That's what we're going to find out now. To answer this question, we are first going to set up a function which is going to give us the amount of money we won as a function of the direction we followed. But how are we going to do that? Well, let's say I've walked d units from the origin. Where are the points I can possibly end up to? Well, I can end up to this point, which is d units from the origin. I can end up also to this point, which is also d units from the origin. Obviously, all the points I can possibly end up to are all going to lie along a quadrant of a circle of radius d, and whose center is the origin. Let's take this point for example, and let's call it point P. How much money have I won by getting to point P? Well, in order to get to point P, I walked d units from the origin in this direction, following an angle theta 1. We call it theta 1. So, in order to get to point P, I covered this distance in the x direction, and I covered this distance in the y direction. We can easily determine these distances. First, let's try to determine the distance we covered in the y direction. Well, with a little bit of trigonometry, we can determine that this is equal to the sine of theta 1 times d, this distance. The same way, we can determine the distance we covered in the x direction, which is equal to cosine of theta1 times d. Now we can easily determine how much money we've won by getting to point P. We just need first to multiply the distance we've covered in the x direction, which is right here, times the money we win by going 1 unit in the x direction. Early on we defined it to be equal to $2. So this will give us the money we won in the x direction, The same way we can determine the money we won in the y direction by multiplying the distance we covered in the y direction times the money we win by going 1 unit in the y direction. I'm calling it S sub y, and we've defined it to be equal to $4. So this will give us the money we won in the y direction. So now, in order to determine the money we won by getting to point P, we just need to add those up. So this will give us cosine of theta1 times d times s sub x plus sine of theta1 times d times s sub y. So this is the money we won by following a direction, the direction theta1. So I'm going to call it the money we won by following the direction theta1. Now we see how the function we wanted to know will look like. We'll call it m for money. This function will be quite useful. We just need to input an angle, theta, and it will give us the money we won by following this angle, or if you prefer, this direction. So the function m, which is a function of theta, will be equal to cosine of theta times d times s sub x plus the sine of theta times d times s sub y. Now if you remember, our goal was to find the direction we needed to choose in order to win as much money as possible. So maybe you can already guess that we're going to use the tool of derivation. Indeed, the function m will hit a maximum when its derivative will be equal to 0. So let's first try to find the first derivative of this function m. This will be the function m prime of theta, and it will be equal to minus sine of theta times d times s sub x plus cosine of theta times d times s sub y. Now if we set m prime of theta to be equal to 0, theta would have to satisfy the following equality. 0 equals minus sine of theta times d times s sub x plus cosine of theta times d times s sub y. We can rearrange this equality to s sub y over s sub x equals sine of theta times d over cosine of theta times d. So if we want m prime of theta to be equal to 0 and our function m to hit a maximum value, we need to satisfy this equality. But if we look more closely to this equality, and if we go back to what we did previously, we have seen that the distance we cover in the y direction is equal to sine of theta times d, and the distance we cover in the x direction is equal to cosine of theta times d. So this equality is basically telling us right now that if we want to grab as much money as possible, we need the we need the distance we cover in the y direction divided by the distance we cover in the x direction to be equal to the ratio s sub y over s sub x. So it's basically telling us right now that if we want to win as much money as possible, we need to follow a line of slope s sub y over s sub x. We absolutely need to follow this direction. So now, how does this all relate to vectors? Well, let's go back to our first example. Let me first erase this. Hop là. Okay. Let's draw the unit vectors. The unit vectors I right here. Let's draw the j unit vector right here. Now let's draw two interesting vectors. Let's draw the s sub x times I unit vectors. In this example, the s sub x was equal to 2. So the x sub x times I vector will look exactly like this. Alright, so this is the x sub x times I vector. Now let's draw another vector, the s sub y times j vector. We've seen that s sub y was equal to 4 in this example. So the s sub y times j vector will look exactly like this. So this is the s sub y times j vector. Now let's do something quite interesting. Let's add those two vectors. We'll get a third vector, a third. And it will look exactly like this. There is something quite interesting about this vector. So this vector is the s sub y j plus s sub x I vector. If you look closely, this vector will have a slope of s sub y over s sub x. So if we choose this direction, we will satisfy the equality we've seen previously. So the direction of greatest increase is the direction this vector points in. The direction you need to choose in this particular situation to win as much money as possible is this direction. Let's say that I've got a function t which gives me the temperature of a metallic plate at different points on this plate. So each point on this plate will be represented by a set of two coordinates x and y. That is why the function t will be a function of two variables x and y. Let's take this point on the plate, for example. Let's call it point P. This point will have coordinates xp and yp. So if we report this on our graph, maybe the point P will be somewhere around here. Point P. And as we've seen, it will have coordinates xp and yp. So the height of this point P will give us its temperature. Now, let's say that I also know that at this point P, the partial derivatives of t with respect to x is equal to 6, and that the partial derivative of t with respect to y is equal to 2. Now what does that mean? That means that at this point P, if I go 1 unit in the x direction, starting from this point P, the temperature will increase by 6 degrees. The same way, if I go 1 unit in the y direction, starting from this point P, the temperature will increase by 2 degrees. Now the question is, starting from this point P on this plate, which direction do I need to choose? Do I need to follow in order to get the maximum increase in temperature? Well, to answer this question, we are first going to draw two interesting vectors. Basically, we are going to do exactly as we did previously. We are first going to draw the vector partial of t with respect to x times I unit vector. So this vector will have the same direction as the I unit vector, and it will be 6 units long. So maybe it will look something like this. The same way, we are going to draw another interesting vector, which is the partial of t with respect to y times j. So it will have the direction of the j unit vector, and it will be 2 units long. So maybe it will look something like this. Now we just need to add those two vectors to get the vector that will point us in the direction of maximum increase in temperature. So this vector will look something like this. And we can project it on the xy plane. It will look something like this. And this is the vector partial of t with respect to x times the I unit vector plus the partial of t with respect to y times the j unit vector. This is what we call the gradient of t at this point P. I forgot the P here. So this is the direction we need to follow, starting from this point P, to get the maximum increase in temperature. That is why the gradient is defined this way. The gradient of t at a given point will be equal to the partial of t with respect to x at this given point times the I unit vector plus the partial of t with respect to y at this given point times the j unit vector.